Hey folks, check this out. The first time ever I know the temperature in my nutrient tank, and it's not just that one. I know the temperature in the grow beds, in the grow bed nutrient tank, in the lower grow bed, and I know the ambient temperature in the greenhouse. And now I'm going to show you how I made it all happen. Ryan Ponicwars over in Thailand said to me if I ever did something with Wi-Fi monitoring temperature and pH, he'd be very interested to learn, and that's what I've done. So I'll show you what's going on. About, where are we now, 14 months ago now, long time ago, I got hold of a couple of these things. It looks like an SD card, but actually it's an entire Wi-Fi internet connected microprocessor, microcontroller thing. Gives you a bunch of input-output pins, talks to the internet. So very easy to connect things onto that, and these things plug into this little breakout board that you can get for a couple of quid. These are about $30, these are probably about $5, so nothing too expensive. And this lets you connect pretty much any sensor or dongle onto Wi-Fi. Now, the other thing I've got is some of these potted encapsulated temperature probes. And these are terribly clever little things, but that's kind of unimportant. It could just be a temperature sensor, but it's a temperature sensor, a whole computer. It takes power on the red and black and sends and receives data on the yellow wire. And that's really all you need to know about it. Okay, I thought I'd show you exactly what I've done here, because it's really not that difficult. Here's my little box of imp bits that I bought December last year, December 2013. This one hasn't even come out the packet yet, so we'll start off, we'll take that out the packet now. Whoop, gone on the floor. And this is exactly the same format as an SD card, and it will fit in an SD card slot, but you can't use it as an SD card because the pins aren't all in the right place, so you might blow something up if you do that. But yeah, that's the card. Here's the breakout board. I have already soldered just here a little bit of wire, so this one's selected on battery rather than USB power, so that socket there won't do anything. And I've added a bunch of pins on the bottom so I can plug it into breadboards and things, but that's it. Plug the card in, and well, of course nothing happens because I haven't got any power on there yet. Let's find a battery. Now, this breakout board has got a little voltage regulator built into it, so although the imp board itself uses 3.3 volts, this thing you can give anything from sort of 3.5 volts up to about 12, 14 volts. I should check the specs, but I know it's safe on 12 volts. So I'm just going to use this little 12 volt battery I've got to power it up. Just got a bit of breadboard to stick this into so I can get power onto it without short circuiting things. So I'm going to hook up the power to this little imp now. And you can see we've got a red flashing light there, which means it hasn't managed to connect to Wi-Fi yet, which isn't really a surprise because it's no idea what my Wi-Fi connection details are. Now, the way you tell it your Wi-Fi connection details, this thing has got stuck in the end there that looks like the red LED. There's actually a little photo transistor behind there listening out for pulses of light, and they give you an application for your mobile phone. I think it's available on iPhone as well. You're not seeing my unlock code. So you've got this Electric Imp application called Blink Up. Once you log into it, it uses the Wi-Fi settings from your phone. So yes, I want to use Jim's house. That is my network. So now I've given it my Wi-Fi password. What you do is point the screen at the light sensor on the back and click Send Blink Up. Now I have found with this, I don't know if it's because I've got a large screen on my phone or because my phone's getting a bit slow, but I found that when I do this Blink Up thing, it tends to work if I hold the imp near the top of the screen, but not so much if I hold it near the bottom. And I think the issue there is that when the phone changes the screen colour, it does a wipe from top to bottom, and it's not always getting the chance to do it. So got to sleep, come on. So I'll hold this against the top of the phone now. Let's see if I can get this all in shot. and send blink up. Point screen at sensor now, and that epilepsy inducing combination of black and white flashes is telling the imp what my Wi-Fi signal ID is and the password for it, or so the theory goes. Well, I finally got it to blink up. Couldn't do it with my phone at all. Switched over to this old tablet and that did the trick in the end and actually worked. So now I've got a green light because it connected to Wi-Fi okay. Now I can show you what I did next. Okay, so you should now be looking at the ide.electricimp.com website, which is where you do all the development for the Imp platform. I was kind of hesitant with this at the start, but I've actually really come to like it now I've used it for a while. Anyway, you can see here you should have an unassigned device, and this is the one we've just blinked up. Ignore this active models stuff, that's stuff I prepared earlier, but this is the one that we just blinked up. So we need something to do with it now. Now, as I always do, I googled the most obvious thing I could think of, which was Electric Imp one wire, because I'm using the Dallas one wire bus, and hey presto, they've produced this tutorial for you, or for me, or for whoever wants to use it. It explains a bit about what the one wire bus is and how it works. We don't care about that at the moment. It tells you that you can do it over a UART, which is actually just a serial port, and how all that works. We'll ignore all of that, you can read that if you want, and then it gives you this nice circuit to connect it all up. This is the Dallas one wire temperature sensor, and it doesn't look quite the same. It looks like a transistor on here. The ones I've got are the same, they're just encapsulated in a metal tube with some potting compound, and then it's to make them waterproof and things like that. My sensors are exactly the same as that, and the two other components are a 4.7k resistor, but anything around that number will do, 5k, 5.1, 6, 7.5, something like that, and a Schottky diode, which is a special diode that's got a very low voltage drop on it. I've just been scavenging these out of old switch mode power supplies, old PC supplies, off motherboards, things like that. They seem to work just fine. I don't think the circuit's too choosy about specifically being this 1N5815 that they list. Certainly I haven't found it to be. Now, I did have a problem with this in that when I hooked it up to the UART on pins 1 and 2, nothing worked whatsoever. I put an oscilloscope on there and there was just no output on those pins. But this unit has another UART on pins 5 and 7, so I plugged it onto there instead, and that worked straight away first time, no problem. So I don't know what was going on with that. Anyway, if you get the same problem with the UART 1.2 not working, try UART 5.7 instead and you might be okay. And then going on, they give you all the code you need for this. So this code here is the code that runs on the device itself. So let's copy and paste that. So you can do view raw, select all, copy, and then back over here we'll create a new model and we'll assign it our device that we just discovered, this 232A3441. So create model, thinking about it, it's done. And there we go, we've now got two active models, temperature, which is here's one I prepared earlier, and temp demo, which has got our newly unwrapped imp board. So I'm going to call this one, if it lets me. You must assign the device to a model in order to change the name. I just did that. Oh, maybe it's because the model's not active yet. Anyway, going over here, we've got this device window is the code that runs on the imp device itself, on the little SD card, and the agent window is code that you run on the Electric Imp's web servers, and they process results to and from the device for you, and then you can call off to your agent code from a different web page or a website. Your agent code can make calls off to other websites. It's generally a very powerful and flexible thing. I'll show you what we do. Anyway, that code that we just copied, we'll paste it into there. We'll check that it all checks out okay. It says it does. I'm going to change this to UART 5.7 instead of 1.2 because that's what worked for me. So we'll check that. It says yep, success, and we hit build and run. And at this point it compiles the code, downloads it to our SD card, and here you can see it's told us we've got 0° temperatures, and every 5 seconds this takes a temperature reading and sends a message back to the server here that tells us what the temperature is. Right, I better build the circuit up quickly then. So I'm not going to talk you through all this bit because it would be a bit boring. I can fast forward through this, but I'll just show you the exact build because it's so simple. Really, anyone can do this. Let's go for it. I need a Zener diode. This is one that I scavenged out of an old PC power supply and soldered a couple of wires on it so it's got some legs to plug into the breadboard. We need a 4.7k resistor, so in my 47 folder. That's it for the circuit. Let's power it up and see what happens. Okay, recording there. Okay, let's power this up and see what happens then. Might work, you never know. That's the good. Found the Wi-Fi. Device is booted up. And it's reading the temperature. So there we are, that's got us a wireless internet connected temperature sensor now. Now, of course that's fine if you just want to measure one temperature. Of course I want to measure more than one set of temperatures because I've got 2 nutrient tanks on the go. I want the external temperature, and it'd be nice to get the temperature of one of my grow beds as well and see how that varies as the water cycles through it once an hour. So next up I thought, right, okay, this one here just reads one temperature sensor. How do we read more? And I discovered if you look further down in this tutorial, they then have a section on multiple devices, and they give you the code for multiple devices. Fantastic! So let's copy that and add that in. Select all, copy, select all, paste, change that to UART 57 instead, build and run. This down. So there we are. Now we can see that it's, instead of just listing us a single temperature, it's actually listing us a device ID on there as well. So brilliant. Okay, let's take that a little bit further then. Let's add some more temperature sensors. So that's the second one. Yeah, it's all in. There we go. So we're powering up again, searching for Wi-Fi, found Wi-Fi, and we're on. And over here we should find, we're now getting, there we are, 2 temperatures at a time. And just for the fun of it, I'm going to hold one of these temperature sensors, and in 5 seconds or less we should get another reading come through. Oh, it's the scroll bars, it's dragging. There we go, so we can see now that we've got one of these temperature sensors has hit nearly 25 degrees and the other one's still at 22. So the one that I'm holding is obviously sensor, this one here ending AA83. Well, we put some more readings in. So what's AA83 doing? There we are, so we're up to nearly 29 degrees on the one I'm holding at the moment. So that's cool, I can use that. I can hook on, I think I can have up to 16 temperature sensors on that. And it's getting me the results back to somewhere on the internet. So the next thing we need to do is work out how to plot a graph of these, because having these pop up in the web browser obviously isn't fantastically useful. So I did my normal thing again, because all I ever do is Google stuff and cut and paste it. Electric Imp one wire graph, and I discovered here, the next link down, from something called Plotly. Now Plotly sounded like something that probably printed graphs, and indeed this is another Electric Imp temperature sensor. They're using a different temperature sensor to me, a TMP36, but another very simple circuit to wire up, and they give you a bunch of code here. So they've got their code that runs on the device, which you're not going to be able to see because that's, oh you are, cool. So that's the code that runs on the device, and they're just reading the temperature sensor in as an analog value there. And they've got function to get the time and date, and where's the one I saw? Here we are, and this thing that was new to me, agent.send new readings. And going back, they also give you the agent code, and the agent code here says, yeah, plotter data using this service called Plotly, and you have to give it a username and your API key. So I signed up for an account and pasted them in, pasted that into the agent code, and I've got that code running over on this board here, which is called first one, which should pop up there. I will fuzz over those two lines so you can't see my login details. But yes, that's it. That's all I've done. So I've taken this original get time code and I've just modified it ever so slightly so that here we are. We send my temperature sensor data instead of the original TMP36 sensor they used. I've also made a couple of other tiny little tweaks here. I've got this reading the hardware voltage because I want to try and detect a low battery condition, and I've set up this on idle function here, which means that when our imp runs out of code to execute, which it does each time it sends the settings back to the server, I put it into a hard sleep for 60 seconds. This basically means it's using effectively no power whatsoever, or kind of the very bare minimum of power, just enough to run its little internal clock. And then 60 seconds later, that'll wake up again, it'll boot up, it'll connect to the Wi-Fi, which it does in under a second, it'll take all the temperature readings and it'll send them over to the server, and then this on the imp server will call the code for Plotly, and the code for Plotly will then go to a website I haven't heard of before, which is called Plotly, or plot.ly. So if I go to my workspace within Plotly, takes a while to load, you can see the three graphs for the three different temperature sensors I had hooked up to my board, and two of these graphs are still going to be getting updates, or one of these graphs is still getting an update because I've moved the temperature sensors over. Should be two of these graphs getting updates, and you can see this has been the temperature in my office since yesterday when I first plugged this board in. So I'll make these graphs publicly available so anyone who wants to take a little peek can peek at them. I'm going to change the names of these, but I think, oh right, nearly ready to put it in the greenhouse. Now, if I take you over to the here's one I prepared earlier section of the desk, because we don't actually need that one, I'm going to move these thermometers over. Thermometers, temperature sensors I suppose would be a more appropriate term. Come over here. So here's one I prepared earlier. Now this is exactly the same circuit, but instead of running it off that little mini lead acid battery, I've just got it running on the battery out of an old TomTom Navigator. I'm actually just charging it up at the moment. This thing uses hardly any power. If I set this to wake up once every 5 minutes and take a temperature sensor reading and send it to the internet, this battery is going to probably last 2, possibly 3 months. This thing pulls kind of 50 milliamps or so when it's on and sending on Wi-Fi, and it's only actually turned on for 4.5 seconds every 5 minutes. So this 2.2 amp hour battery is going to last for absolutely ages. So I'll plug these back onto this board again. I'm actually going to be very naughty and do it with the power on, but I don't anticipate a problem. Famous last words. This should start all my graphs updating again. go, that's all three of them plugged back in there. Get those pins to sit down a bit. So that'll start all my graphs updating. My battery is actually now charged, so I can unplug that from the power supply now. And this is running as a standalone device. I can move this anywhere I've got a Wi-Fi signal, and it's going to give me 3 temperature sensor readings, which you can't see. Oh, there you go, you can see them. And it's going to give me the sensor readings from these 3 different temperature sensors. Now, I've got a few more little tweaks to do before I put it in the greenhouse. That one's just woken up. It's going to get Wi-Fi, and it's sent the readings, and it's gone back to sleep. And that's it. It's awake for that long, and I'm going to have it running once every 5 minutes, so it's hardly going to use any battery power. Anyway, these probes here, absolutely perfect. I'm going to dip them in the nutrient tanks. The only problem is the wires aren't long enough. So what I'm going to do is I'm going to run up a long bus wire that can run along one wall of the greenhouse, and then I can connect multiple temperature sensors onto that as individual drops. So I'm going to wire that up now, and you can join me in the greenhouse in a minute. Well, here we go folks, out in the greenhouse now. I've strung all of those along in a line down a bit of Ethernet cable that I got when they installed my internet connection. So now I'm just going to drop one sensor in each of those tubs, one in the bed, so actually I could do 2 because that tub's empty at the moment. And I'm going to put the control unit up there and have an ambient sensor there. Let me get that. Right, so there we go. I've got the Imp board and breadboard stuck up in a little propagator tray, just in case it gets any drips. I should close the vent on that, just to stop any drips of water getting on it or anything like that. It does get rather humid in here. And then I've got sensor there for ambient air. I've got a sensor in this raised bed. I've got a sensor in this raised bed. I've got one in that nutrient tank and one in that nutrient tank. So that's 5 altogether. That tank's still empty, but 5 sensors altogether. Right, I'm going to go and plot some graphs now. Right, okay, so you can see I've got my new results coming in from the greenhouse now. Device 1 is at 12 degrees, and we've got different temperatures for the 4 other devices. The next thing we need to do is assign names to this. Now I've actually made a map out so I know which one of these devices is which, but I'm just going to slightly tweak this code up here and make it so it puts names on the graphs, and then I'll give you a look at the graphs. Okay, so I've made my little code change here. So this is just tying the serial numbers up to different locations. As I say, I worked out the sensors in advance, and now I've done all of that. Is this window visible? Yes. Here's my little Plotly window. So there's my lower NFT tank temperature, and that's hit 23 now. I'd like to be running that about 20 degrees, so I'm going to go out and turn down the heater in there a little bit. The upper grow bed is around about 12 degrees C. There's not much data yet because it's only been in there for a few minutes. By the time I've finished editing this video and uploaded it, you'll be able to see a lot more of this. The grow bed nutrients are running just over 20 degrees C, which is fine. I want them at 20. The lower of the 2 grow beds is a bit warmer than the upper one. I suppose it's getting some heat from underneath it from the heated nutrient tanks. And our ambient temperature in the greenhouse was 10 degrees, and it's dropping. It's gone dark outside now. But for the first time ever, I'll find out how cold it actually gets in there. We're due a cold spell over the weekend, so we'll see how we do when it's -3, -4 outside. And finally, I've got the supply voltage graphed here. This is actually the output voltage of the voltage regulator, but I was playing around with it earlier on, and I see that the thing actually keeps running down to about 2.9 volts. As I've got it on a single lithium cell, that's pretty much perfect, because when the battery starts to go low, this voltage will drop from 3.3, and I'll know that the battery's running out. So I'm going to put links in for all these graphs below somewhere. If anyone cares to have a look what temperatures things are at, you know, bit of fun. But since Ryan asked for Wi-Fi temperature monitoring, I thought I'd kick the ball off. Obviously I'm going to add on more sensors to this in the future, but for now I think this will do for today. So I hope you enjoyed that, folks. I'm going to put all the source code that I used here down in the description underneath the video, so if anyone wants a copy of it, that's where you'll find it. Hope this comes in somewhat useful to someone. This is obviously part of my mixologist project, but this is just getting started. Unfortunately, I've got to go and do things which are work next week, so it's going to slow me down on this somewhat. what I've been able to do in a couple of days will probably start taking a couple of weekends. Anyway, thanks for watching, folks. Cheers.